The mercuric challenge has been added to the cells of an apparently healthy donor. We notice there is an immediate thickening with rouleau factor setting in among the erythrocytes. High-energy phosphate bond expenditure in the PMN is evidenced by the bright white color of its granules. We note that these cells have been treated now for less than 1 minute. In the time frame between 2 and 4 minutes after exposure, we see dramatic thickening of the membranes. Lipid stripping is beginning to occur along many of the cell surfaces. And in this animated graphic, we can show you how this cellular phenomena takes place and how the actual content of the cell begins to shrink. Moving ahead in the time frame to the 5 to 7 minute period, many of the cells have dramatically reduced to a smaller size. Membranes are thickened. We notice that many of these cells now have no shimmer pattern. Function has been dramatically impaired, if in fact not completely lost. Now, remembering this image, let me also return with you to those same cells when they were exposed only for 30 to 60 seconds. We notice that the changes are not only marked, but will be very easily seen by any observer. Mercury is certainly not the only toxic material that induces these kinds of changes. Let me show you some changes that are induced by other metallic materials, as well as fluoride. These cells have been exposed to aluminum salts at very dilute solutions of 1 part per 10 million. We note that although the changes are not identical to those seen with mercury, they are very pronounced. Remember that these cells looked quite healthy when they began their exposure. Beryllium is often used in orthodontic and other non-precious metallic materials. We note that these cells have also been severely changed from the normal images seen earlier. Cadmium also affects cells, and we notice that it can be used when pink pigment is needed, as in denture materials, and it can also be found in certain stainless steel formularies. Again, these cells all began as normal. Copper is often alloyed with gold and is used in many amalgam formularies. We notice here that the red cells have changed, but in particular we note the unusual activity levels that are stimulated in the white blood cells, and note that the function of these cells is severely compromised when this kind of exposure takes place. Copper isn't the only thing that causes problems with white blood cells. Notice the intense activity generated with a little dilute fluoride. Fluoride also causes red cells to undergo a peculiar clumping, and although they can be mechanically teased apart, they still reaggregate in such concentrations that we see a red coloration from hemoglobin. Gold is often described as the noble metal of dentistry, and here we see the reason. Although about 1% of the population adversely react with gold, we note that most of these cells remain very normal and their function and appearance are as expected. Iron salts are certainly not benign, and in the rust forms or the inorganic salt forms, we see that many of the cells lose their characteristic size and shape and tend to round up. Iron can have a very deleterious effect, and hemoglobin levels can be affected. This is at 1 part per 10 million exposure. Nickel has a very gross and pronounced effect on cells. This is the same material used in so many wires and appliances that are applied orthodontically. And please note that when this happens, it is not unusual that nickel induces double DNA peaking in the lymphocytes, a premalignant indicator. Silver is certainly not the benign metal that it is represented